One of the ones that I think makes the most difference for student learning in an entire class is change one thing problems.
Okay, so today on Change One Thing, we're going to talk about change one thing problems. So it's a little bit, I don't know, is that meta?
Yeah?
But I think that our listeners and viewers will be able to follow us. So you have a strategy within the Change One Thing umbrella called a Change One Thing problem. Tell
Yes.
us about that.
This started because I kept thinking about the fact that I always want my students to be able to reason with whatever they're learning. I want them to be able to think about it and solve problems. And of course, for me, biology and science is about solving problems. But my students were perceiving most of what they were learning as memorizing. Even when we talked with them about the problem solving, they still had a tendency to think most of what I'm doing is memorizing. And it was true that a lot of what they were doing in their studying was memorizing. It never worked for me to say, well, just think about it or just solve problems until I changed my language and stumbled over the terminology change one thing problems. And the idea for a student is that both in class and on exams, I'm going to give you change one thing problems in which I take the systems you've been learning and hopefully understand, and I'm going to change one thing, and in a multiple choice question or a free response question, you are going to tell me, if I change that thing, here's what I would expect to happen. That change in language made students absorb the idea and internalize it in a way that they had not with any of the other kind of language I had used. And I started seeing in course evaluations and then in some of my surveys of graduating seniors, I started hearing people say that one of the most important pieces of their studying was doing change one thing problems, including doing their own change one thing problems. And I think that's one of the powerful pieces of it is I can ask those questions and they can learn how to solve other people's change one thing problems. But once they have an idea about something, which might be an economic system, something in biology or chemistry or literature, they can pick anything and change it. The simplest way is just to take it out. The next simplest is to make it bigger or make it smaller, more important or less important. They can also change the timing. There's an endless number of things they can change. And it's a really useful self-assessment technique for students to test, do I really understand it? Have I just memorized it but can't work with it? Or do I really understand it in a way that lets me work with it? They can do that either with my change one thing problems, but with a little coaching, and it does take some coaching for them to learn how to ask their own. They can ask their own change one thing problems, and if they can't solve them, then they know they don't understand it well enough, and they need to figure out what am I missing, and either figure it out for themselves or come to me and ask me about, okay, I'm stuck here. This is not making sense. That helped me a huge amount when I was setting up exam questions, or of course it can also be essay questions, can be paper topics for students. And that helped a huge amount in getting my students to perform better on my exams. I can't say exactly which kinds of changes I've made over time made the biggest difference, but I can tell you that when I arrived here, the means on my exams were typically around 65%. I was trying to have every question involve some kind of thinking or problem solving. And so the students needed to both show me you understand it, that was part of the credit, and then be able to solve the problem. And they were pretty good at showing me they understood things, but they were really struggling to solve problems. And over time, my means steadily went up on the same kinds of exams to the point where in some classes they can be in the high 80s on some exams. And it's not because I made the material or the exams easier, it's because the students are better at getting it. In fact, I remember feeling I had an ethical issue here. If I didn't want to give too many high grades, I needed to grade more harshly or make the course harder. But the students were actually mastering material at a higher level than they had in the past. And I felt like if I think about it over time, I'm being unfair to today's students by making them meet a higher standard than I used to require.
Just because you became a more effective instructor.
They became effective learners. I guess, yes, I became a more effective instructor, but they were getting better. And the change one thing problems were a big part of that. Another piece that came out of this kind of reasoning is when you ask these questions, there's often more than one way to logically respond to the question. And I started shifting to a different way for my students to think about the answers to a lot of my exam questions. I started telling them, this is actually another change one thing pedagogically, I started telling them, I do not want answers on your exams because you think that's what I want you to put down. I want answers you can defend. I want answers that are logical based on what I expect you to know. And if you're logical based on what I expect you to know, I will give you credit for that. Even if it's wrong, I may write on your answer, this is actually wrong for a reason you don't know, and mention that. But it's logical based on what I expect you to know, full credit. Or maybe you missed one thing that took you in the wrong direction, so it's a point off. And students tell me that's really unsettling initially, but over time, they feel much more confident about their answers. And I've had students tell me, when I was writing it down, I was pretty sure it wasn't what you intended. But if I knew that if you took off points, I knew exactly how I was going to defend that answer, and I knew it was logical. When students feel that there's a right answer, when they feel like there's always a right answer to a question, that tends to push them to think, I have to learn that right answer. I either have to memorize that right answer, or I have to have a procedure that's going to bring me unerringly to that right answer for exams.
Just like in scientific research. That's
Right.
how everything works, right?
And it tends to make them feel like there is one solution to every problem. In some disciplines, there may be one solution. If you're doing 2 + 2, there's one solution to that. But in real life, in the kinds of logic and reasoning that we use in real life, usually there's not one solution. There are a series of logical solutions, and which ones might be the best one to actually try depends a lot on what are the things you already know or the assumptions you have to make. That also is true in biology. If you're making a prediction you want to test in a scientific experiment, or you want to try a treatment for a patient in medicine, you have a set of facts that you have some assumptions about the variables you can't control, and in biology and medicine there are always variables you can't control. So you have some assumptions about what those might be, and then you have to come up with a logical, defendable course of action from those. And though that's usually one of a number of possible solutions. That kind of thinking is what I really want my students to be able to do. Probably half of my students are pre-medical students. I want my physicians to be really good at logical thinking based on what they know. I want them to realize, hey, if I'm wrong in this assumption, or if this test is flawed, I'm going to have the wrong answer, and I'm going to be aware of that. So when I monitor my patient after treatment, I want to be aware of that possible flaw, because if it doesn't look quite right, that says I got to re-examine those other things. Maybe I need to redo a test. Maybe I need to change an assumption. Everybody else in my class is going to be a patient. I want them to go into their medical treatment or anything else in life and be able to think logically and reasonably, be aware that their logical answers are going to depend upon the facts they have, and they're going to depend upon the assumptions they make, and be comfortable with the idea that, okay, this is my best or maybe my wisest choice right now, but it's not necessarily going to be the one that I end up with. And I want them to be thinking about that in their courses, because those are skills I want them to build for any career in biology, but they're also the skills I want any student to build before they graduate.
Yeah, and I think that's a point that also would resonate with a lot of our instructors. I have consultations where instructors across disciplines will say, I'm not interested in teaching them about supply and demand. I want them to think like an economist. So that really echoes what you're saying here. You're really just wanting them to build those critical thinking skills and be able to apply them to messy, poorly defined problems, which is life.
Right.
Okay, that makes sense. So we hope you feel inspired to go out and change one thing in your teaching, and we want to hear from you. So please email us at stli@wm.edu. That's STLI@wm.edu if you would like to make an appearance here in Studio 36 or virtually in our virtual podcasting studio.